Recording in progress. Welcome to our second material discussion. The first discussion, we talked about reflectivity, which basically is using the base and the specular section of the AI standard surface. And now we're going to add in the transmission section, which is where we deal with transparency and refractions, and of course, transmission. So, office hours tomorrow, Thursday, I will be 10 to 4 on Discord. Frank will be running the online open lab on Thursdays, and this is optional. This is for campus and online students. We can answer a lot of questions. We can even screen share in Discord, but sometimes when you have more than one person, it's kind of cumbersome. So the Zoom Open Lab is a much better option for us. Okay. So today, as I mentioned, transmission, refractions, transparency. We'll be dealing with the index of refraction, which we dealt with ever so slightly on Friday. And we're going to be dealing, obviously, with the AI standard surface and how it deals with refractions. So don't forget, tomorrow is when Project 6 is due. You'll have the material discussion and also the research discussion that we talked about on Friday. Just kind of give you guys a heads up so you can start doing research on a topic that interests you. All right. So does anybody have any questions from last time? Brianna's good. Okay. Clifton's good. Kentavious is good. You know, we're going to be reviewing some of that. We're not going to dive too much into detail on just the standard reflective part of the surface. We're going to focus mainly on glass and liquid today. Very simple glass, simple liquids. And we are also going to do, we'll focus a little bit back on metal, kind of go over that whole process because it can seem to be daunting. Unfortunately, to make proper glass in Arnold, the transmission refraction part is not really a whole lot simpler. So that's only because Arnold breaks it up into two sections, whereas other software packages, kind of encompass glass or the refraction part, transmission part in one surface or in one section. They kind of combine everything. But it's okay. We just have to learn the separate parts and how they work together. All right. So when we have direct transmission, that means a light ray can pass through a surface, a medium, a fluid, however you want to look at it, and is not obstructed. That means it's not blocked, doesn't bounce off of the medium. It passes through more or less unaltered in its path. An example of that would be air. We think of air, as a gas. It's also really a fluid that we kind of swim around in all day. And that's, how we breathe. But air behaves a lot like liquids in its physics properties. So when you have a light ray coming from a light source, okay, it hits a surface at a perfectly perpendicular angle, meaning perfect 90-degree hit. That surface that the ray hits is clear, it's clean. That light ray will usually pass through unobstructed. Now, it's already passed through air, which, as we talked about, is a fluid. Now, as long as the air is relatively free from moisture, relatively free from particles, contaminants, pollutants, where there aren't little particles floating in the air like smoke or, just dust, where light rays can hit those little particles and kind of get off their course. If the air is fairly clean, the surface is fairly clear, that light ray passes directly through it. Okay, that is simple direct transmission. Now, when we have a light ray that hits a surface at anything other than a perfectly perpendicular angle, an incident angle, angle of incidence, could be, instead of hitting it at 0, it hits it like 001. Right? Even that little bit will alter the course of the light ray on its path. Now, the air still may be clear, the glass still may be clear, but when it hits it at an angle, it's going to respond to the angle that it hits the surface, the glass, with, and it will bend according to how thick the glass is, what kind of glass it is, does it, what is it constructed of, basically. If it's simple, clear glass and it's relatively pure, high quality, it's probably not going to bend all that much. Whereas if you hit it and it's like basic production glass, where they have a certain level of imperfections that are allowed in the product, then the light ray may bend or refract more as it passes through. Okay, so the incident ray goes through the air relatively unobstructed, hits that surface. That surface happens to be glass. It's got an index of refraction, okay, which means that it has a property that responds to light in a certain way. It reflects and it refracts according to how it was measured, which is that index of refraction. So we played around with it a little bit last time in our simple, plastic, where the default index of refraction is 1.5. We wound up using, for plastic, we went 1.55, which made it slightly more reflective. So it reflected a little bit differently. We weren't doing transparent material, so the light ray didn't pass through. Our camera ray didn't pass through. So, we played around with it a little bit, but we really didn't get to see the result of something bending as it passed through, which we will today. All right, so many of you guys have modeled this object, a simple glass. Okay, now, if you are a modeler and you've learned how to model this, a lot of times you use like a, CV curve, right? So you wind up, having a start point somewhere in the middle of the object, right? Bottom somewhere maybe up in here, right? And you do a profile. You come up, you come down, and you usually stop somewhere in here, right? Then you do a revolve, output polys, and you've got yourself a really nice surface. Okay, and we have you build it with an inner and an outer wall, because that little space in between there, even though theoretically we think of it as air or a vacuum in Maya, it actually is filled with the material property that is assigned to the surface. And usually by default, it's Lambert. We switch it over to AI standard. But in the case of an ordinary drinking glass, we make it a property. That property is glass. All right, so Here we are. So we have our light ray coming in. And a light ray hits that surface. Okay, that surface then gets queried by the renderer or by whatever process is being displayed. So light ray, camera ray hits the surface, says, what are you made of? The surface says, hey, I'm glass. I've got an index of refraction of 1.5. I'm mostly transparent. And the light ray goes, okay, or the light or camera ray goes through and says, okay, great. I will bend according to your index of refraction. It then will exit, and immediately exiting, it realizes there is nothing in here. Okay, so that nothing in here translates to what in the real world? We are outside of that glass material. What is inside? What's inside in the real world, inside an empty glass? Anybody? Air, exactly. Thank you, Brianna. So inside here, it's empty. We have air. Air has an index of refraction of 1.0, which is very neutral. It doesn't, reflect. It doesn't bend light. It simply allows something to pass through unaltered. All right, so we have air inside. So our light ray exits and goes, oh, okay. It goes back on its path, sort of. We come down and it hits the inside of the glass again. Says, hey, what are you? Hey, I'm glass. You have to bend according to my index of refraction. So again, the ray bends, exits outside, probably air outside as well, and continues on its way. So this is really important because we're trying to figure out how many points of entry and exit that our ray goes through to get through an object, especially when the object is supposed to be transparent and it is supposed to be glass. So in reality, we've got 1, 2, 3, 4. So our simple little ray, in this case, we're shining a light through a surface, has 4 entry exit points. Now, that's all fine and well. Most renderers have their settings set up to handle a simple single drinking glass, which means they usually have, the ability to have the ray go through 4 surfaces. Now, that's all fine and well. What happens if you have a glass in front of a glass and the camera or the light has to pass through 2 surfaces? So how many surfaces would that ray have to go through with 2 glasses? All you have to do, figure out what it is for one, double it. So we have glass in front of glass. Very poorly drawn glass. But you get the idea. It's got an inside, it's got an outside, just like the other glass. So here, we would have 4 surfaces. Over here, we would have 4 surfaces. Where it overlaps here in the middle. How many surfaces would our ray have to go through there? Anybody? Nathaniel? Kentavious? Derek? Darian, sorry. Clifton? Brianna says 8, question mark. Kentavious says 8. Yes, 8 would be the answer. That would be where they overlap, each having 4, total 8. All fine and well. What happens if we have liquid inside the glass? So we put liquid in the glass. Now, for this, you need to kind of figure out how is that liquid looked at. So first off, does the liquid have a hollow center? Meaning, does it have walls? Is there nothing inside? Right. Kentavious says no, absolutely. The answer is no. Okay, if we were to take this glass filled with water, put it in the freezer, right? Take it out when it was frozen, and we could miraculously warm enough on the outside for that big blob of frozen liquid to come out, it would be a big solid chunk. So that's kind of how you have to look at the contents of a glass, right? Doesn't matter what it is, water, juice, wine, milk, any liquid that's in a glass is going to be treated sort of like a solid. Now, I say solid in a very loose sense. I don't mean solid that you can't see through it, because, if the ice is clear enough and you don't have, if you freeze it the right way, it's very clear. It's just really shiny and bends light a lot when you look through it. But that's kind of what you have to think of when you are dealing with a liquid in a glass. For one thing, it's going to be modeled as a solid. Did they teach you guys how to model liquids in either 3DF or model creation or any of the other classes you had? They didn't have you guys like select faces on the inside of a glass. You duplicate them, scale them in ever so slightly, cap off the top, and then you've got a shape that conforms to your modeled object, no matter how elegant or complex it seems to be. All right, well, when you do that, you wind up with a really good shape of the object. All right, so for this, let's go to orange. All right, so here is our liquid in the glass. going to draw it off. All right, so now we've got a couple other things going on. We've got more than 4 surfaces for the ray to go through. All right, so we still have our glass here. Oh, and I got rid of it. Oh, that's all right. Wasn't that attached to it anyway. Besides, it was orange. You get the idea. Okay. So we got glass. We have air up here. This, we'll say, is water. All right, so air 1.0, water 1.3332, somewhere around there. So we don't really need to worry about air. Like I said, air is neutral. Anywhere that you've got air, your ray is going to pass through pretty much unobstructed. All right, so we've got a few more entry points here. So we've got the initial entry point where it hits the glass, says, what are you? Right? It bends according to the index of refraction, exits, and immediately hits the liquid. The liquid says, hey, I am a solid surface or a solid object. I'm water. I'm 1.33, going to bend according to the index of refraction. It's going to exit, hit the glass immediately, bend again, and then exit out. So now we've got more than 4 simple entry and exit points. We've got our initial here, got it here. And we've got another one immediately after it leaves the glass. Okay, exits the liquid, hits the glass, goes through the glass, and exits out to the air. So how many surfaces do we now have our liquid or our ray going through? No, let's count them. You got 1. You got 2. This one makes 3, 4. Come on, you know where this is going. 5, 7. Right? Got 7 surfaces. Six. Thank you. Yes. I was going to the dark side there for a minute. Yes. 6. So simple container, glass, drinking glass, however you want to look at it. Could be a vase filled with water. We have 4 for the object itself. We have 2 for the liquid inside, right? Got an entry point. It's a solid fluid, water, and 1 more for the exit. So the glass has 4. The liquid has 2. Together, they make 6. Now, if you have that same scenario where you have glass in front of glass, Whew, that was just nasty. All right. All right, so we have an inner and an outer surface. This one has liquid. This one has liquid. Right, so we know the worst case scenario here is going to be, we've got 6 here. We've got 6 here. What about where they overlap? How many surfaces for gamma ray or a light ray to go through? Anybody? Brianna, Clifton, Darian, Derek, Kentavious, Nathaniel? What do we got going on there? Right, Frank says 6-6. If we have a third glass, then you could have your 6-6-6, Frank. Right, everybody, anybody there? Hello. All I hear are crickets. I hear nothing, actually. Just the sound of my voice echoing in a big empty room. Come back to me, come back to me, come back to me. It is 12, Brianna. Thank you. So the overlap is 12. All right, I'm just trying to wake the cobwebs up here because this stuff is important when you go to set your render settings. You may be rendering and find, oh, I can't see all the way through my object. I wonder why. Well, then you have to go check your render settings to make sure that it's set up to allow enough rays to go through many objects or many surfaces. It doesn't really care. It's all just considered surfaces. How many objects does it have to go through? But it's simple enough to feel like a trick question every time. Yeah, I can kind of understand that, Darian, but it really is not a trick question. Just trying to make the point that the obvious, even though it may seem simple, is the answer. So, good point. All right. So, we are still working with conservation of energy. This time we are pulling in refractive energy or transmission in the case of Arnold. All right, so diffuse, specular, transmission. When we started to add specular in, we pulled energy from the base. Now we're going to add transmission. Guess what? We're basically going to shut down the base. The base is not going to be a factor for transmission. Really? Come on, get back there. Give me my tools. So when we are making glass, we're not dealing with base energy at all. We've stolen it all. The difference is split between specular and transmission. Now, some renderers combine this into one very neat, convenient, tidy little package, but Arnold keeps them separate, which means we just need to be aware of what each is bringing to the party. Okay, so for example, under specular, this is where we're going to get our index of refraction. This is where we're going to get our reflectivity. Reflectivity is going to be based off this index of refraction. right? All the transparency is going to come from transmission. So for glass, most of the energy is going to be in transmission, and some of the energy is going to come from specular. All right. So as I mentioned, specular and transmission work together. Okay. When we create glass, we turn the base off, which means we take the weight, take it to zero. That will give us an accurate, a physically accurate pure glass. Most renderers, you have to turn off the base or the diffuse in order to make sure none of that energy bleeds into the transparency or to the reflectivity. Hence, kind of muddy the waters. All right, now, specular weight, that's going to control the reflectivity, the roughness of the reflectivity, and the index of refraction. Arnold says you're making glass, leave it at 1. Specular color, leave it at white. The only time we ever change specular color is, anybody remember from last time? When we made metal. We had copper. We had to add some color to the specular color to get the edges of our metal to be coppery in color, right? But in glass, we want all the reflectivity. We want that edge to be white and any color to come in from our environment. All right, so specular roughness, this adjusts how much the reflective or specular rays get dispersed or diffused. So quick example of what that looks like. Looks okay, not really completely accurate, but it looks all right. Index of refraction, this is where we change it. If it's water, if it's wine, if it's juice, if it's, anything. Could be glass balls filled inside a glass, right? Index of refraction is going to be important. So that takes care of the specular part, what it's bringing to the party. And to be honest, most of these settings are default, right? You make a brand new AI standard material, the weight's all the way up. The spec color is white. The roughness is 0.2. Roughness, you adjust. Index of refraction 1.5, built for glass right away. All right, the transmission part. Now, normally, depending on the renderer you're using, you just simply turn up the weight. That gives you the transparency, and you change the transmission color. All the color for glass is going to come from transmission. You want blue glass, you're going to put blue here. You want red, you're going to put red here. You want green, you're going to put green here. You want pink, you're going to put pink here. All right, now, with Arnold, though, you will see when we go to demo this that we don't automatically get shadows in clear glass, which is very, very eerie. So there is a fix, and it involves a couple of Maya utilities to get those shadows to appear. So I'm just going to mention that we're going to use something called a gamma correct, couple simple tweaks in it, and the sampler info. We really don't change anything in there. We just connect it to the right places, and our shadows will show up. Now, in transmission, we also have this extra roughness control, right? So this is the roughness of the glass. Compare that with the roughness of the specular. Looks a little bit different. Okay, specular glass. The actual accurate result is when the two work together. Arnold says transmission roughness should equal the spec roughness and the transmission extra roughness. So if you're trying to get a frosted glass, you need to make sure you've got roughness in the specular and roughness in the transmission. One without the other, this gives it a very dull look. This gives it kind of a shinier look, but together, that's where it really looks like the object is frosted when you have both. So just note to self, the amount of roughness that you're going to need for your glass will be based on your reference. If you have reference for a rough piece of glass, it's going to be a combination of roughness in specular and roughness in transmission. So whatever you do to one, you want to keep the two close together so it looks physically accurate. Does that make sense? It's a little bit weird because, like I said, some renderers, you have a roughness control and it handles the spec and the transmission together, right? But Arnold, everything is completely broken up. Okay, Brianna said, yes, makes sense. Okay, good, good, good. All right, now, when we are making glass, we're also going to go under the advanced section and turn caustics on. Turning on caustics will give the glass a little more sparkle. Now, a lot of times people think of caustics and they look something like this. Actually, I have some photos that I took of glass objects outside. Let me get the empty glass. There we go. So took some reference outside, and you can see I've got a pretty decent looking shadow for my clear glass. So this was outside probably like, I don't know, 2 o'clock in the afternoon, maybe 1 o'clock. And you can see this little glass here, it's green, right? I get green, I've got a nice shadow around it. We also have this really super sparkly, almost looks like pool reflections. Okay, technically, this is what most people think of when they hear caustics. We don't get that for free in Arnold. In fact, we don't even really address it that much because it is a complicated procedure to get. But turning on this switch does give the glass a little more sparkle, which I will show you when we go and demo. So a little bit of extra work to get this to look good. Now, one other thing we do also is, since we are using, where are we? Here. Since we're using these two little utilities, a gamma correct and a sampler, to get our glass shadows, we need to crank up the indirect specular, not light, but the ability for the material to take more in. So we turn it from the default of 1 to 1.1. That usually is enough to just push it a little more. Now, if we are making window panes, like double glass, double pane windows, or single pane or a hollow glass ornament, down under geometry, there's a little switch called thin walled. You turn that on, and that will allow your glass to look reflective, but not allow light to bend as it passes through. It basically bypasses all that calculation. Why? Well, if you're modeling or working for, say, an architect, you're doing a rendering visualization of an office for somebody, they've got a lot of windows, and you're modeling the outside of the windows, well, chances are you're not going to model each window as a cube, right? You're going to model it probably as a plane to save time. And in reality, that's about to scale how the glass would appear. You know, if you're a big giant and you're putting in glass, it would be very, very thin, like paper thin. So instead of calculating unnecessary refractions, we're only calculating the reflectivity and how it lets light through. We're not actually bending light. So it really is a time saver. And in a building, when you go outside, you really can't see the light refract unless, of course, you've got a bowed window or you've got, you know, kind of a wavy effect in your window and you can see things kind of bend all over. That's a different case. But when they're just ordinary window panes put in a building, they're going to be flat. They're going to be fairly clear, or maybe they're tinted a little bit, but you're not going to see refraction unless for some reason you're doing some kind of weird cutaway. So thin-walled, we're going to get a chance to use that for the interior scene. We've got glass geometry that Frank modeled for the interior windows. We're going to put the windows, turn the geometry visible again because it is on a separate display layer. It's not going to be visible. And we're basically going to make it glass. So when you're inside, you can see a little bit of reflectivity, but you can still see through it. You're probably going to see more reflectivity at night than you are during the day, just like you do in the real world. All right, so I have a couple of renders here that I did. Simple sphere, dome light, right? Air. Index of refraction, 1.0. Now, for air, you know, if I did not have a shadow here, you would say there's no object there. So the object has a shadow just because I wanted to verify with you that, yep, there's an object there. It's just air. It's neutral, more or less invisible. You can't see any reflectivity. You can't see any refraction. Air, simple transmission. Water, 1.33. Right? So now we get more reflectivity. You can see we get light bending as it passes through. The camera rays bend according to the index of refraction. We get a shadow. All right. Crank it up to glass, 1.5, 1.52, somewhere in there. It reflects a little more and refracts a little more. It's a little bit denser. We get a little more of a substantial shadow. We go up to a diamond, like 2.42, which is very dense. It's going to bend light a lot, and it's going to, you know, reflect light an awful lot. Welcome, Marie. So as the index of refraction goes up, our light rays will bend and distort more as they pass through. They will also reflect more. Because remember, glass is a combination of mostly transparency, transmission, refraction, and a percentage of reflectivity. And that's all based on this index of refraction. All right, so Arnold, the Arnold renderer section, the Arnold tab, down under ray depth, global control for the max number of specular bounces in a scene and transmission bounces. The total by default is 10. So total's 10, specular's 10, transmission is 10. 10 is not a bad number. So there is plenty here, but if you find you've got glass in front of glass, in front of glass, and you've got, you know, one of those objects, probably the one in the back, is not letting light through it, it's probably because you need to crank up the specular, the transmission, and the total. When you do, your render times are going to go up. Now, these settings are default. The good thing is, if you're using just diffuse in your scene, like we were for projects 1 through 5, right, you're not going to notice much of an increase in render time. As soon as we start adding reflective materials, and now we're going to add in transparent materials, okay, our render times are going to start to go up because now all the reflectivity, all the transmission, the refraction's going to come into play. Which leads me to another point. Now, this is before we had denoise filters. All right, so render time could take anywhere from, for glass, metal, just basic material properties, could take anywhere from 20 minutes to an hour. Right here, scene set up, there's really no glass overlap. Very little, reflectivity, got a little bit of metal reflectivity bouncing off of and through the glass here. But as soon as the camera angle changes, same render settings, camera angle changes. Now I've got glass overlap. Now my render times are going to double. That's because the camera is seeing things differently. So you can see we've got a lot of refraction. We've got 2 glass objects in front of each other. So here we've got a total of 8 objects. Right? This bottle, come on, you're supposed to give me that. There we go. So this bottle has 4, right? Outer wall, inner wall, goes through, hits an inner wall, hits an outer wall. Same thing with the vase. When they overlap, we get 8. Over here, this is called a Klein bottle. Love this bottle. It's actually got a neck that goes through the body of the bottle. So you fill the object down here at the base. Okay, so it has a neck that's inside the bottle. So in reality, this bottle has 4. The neck also has 4. Where the 2 overlap, we have 8 here also. So over here in this green, it's like an hour-shaped glass bottle. It has a lip on it that is kind of a mushroom, kind of looks like this. So at some point, you're going to have some overlap. So normally this would be 4, but up here in these sections where these 2 are in front of each other, we're going to have 8. So consequently, we had 8 going on here, but the camera wasn't that close. The extra overlap, and this is really big overlap here, and much closer to the camera, it's going to take a lot longer. It doubled the render time. Bottom line. All right. Any questions so far? All right, Brianna's good. Nathaniel's good. Marie, I know you just joined us. You'll probably need to watch the beginning part of lecture archive to get caught up. Kentavious is good. Derek, Darian. Derek is good. You already said that. Okay, good. Brianna said she's good. All right. So let's take a look at the process of making glass in the exterior scene. All right, so what I'm going to do is what we're going to do is work on getting glass for the exterior Zen garden scene. Kind of give you an idea, show you the workflow, and then I've got a checklist for you, which should help a little bit. Get RenderMan, then we got to get Arnold. All right. So what I'm going to do is, let me set my project. Project 6. Yeah, let's go Zen Garden here. And I've got a finalized lighting that I got here. I'm going to use day because it's a lot easier to see, glass and how it operates. Let's also take a look at what the requirements are for Project 6. We've got our milestones here. So we've got the refraction milestone, right? So in addition to, assigning material properties to all the reflective parts, we've got glass in the interior and we've got glass in the exterior. Okay, the exterior, everything is spelled out. We've got a wine glass, we've got wine geometry inside the glass, and an empty wine bottle. Those are your 3 glass objects for the exterior. For the interior, okay, we've got window geometry we're going to turn on when we get into the interior environment after we get done the exterior, right? We're going to turn that geometry on. We're going to make it glass, and we're going to make it thin-walled. There are additional objects in there. There's a vase, which is above the TV, right? That needs to be, we're going to spell it out too, it needs to be clear glass, right? Our glass bottle is on a shelf right underneath of the vase. Got a rectangle bottle next to the sofa on the table, and the Klein bottle that is on the actual computer desk. Like with anything else, you are going to find reference first. Find reference for what you want. Then you assign a new material to the object. Then you go through the process of making it glass, which is going to be step by step in order so you don't forget. All right, so like I said, we've got it spelled out. The wine glass needs to be clear. We want to know you can make clear glass in both exercises. Like I said, the vase is clear. The wine glass is clear. The wine inside the glass will be a color based on your reference. Red wine, white wine, Zinfandel, rosé, pink, however you want to look at it. All right. So, exterior scene. It's going to be in this wine, cheese, bread group. Right? We got the wine glass group, and there's a wine bottle group here too. So wine bottle geometry, we've got also wine label. Now the wine label we are not using for this exercise. Okay, place the wine label geometry on a display layer and turn it off. Label that display layer so you know what it is. So if you choose to do this scene in project 7, you know where it is, it's labeled, you turn it on, we use it. So select the label geometry, throw it on a display layer. Turn visibility off. And now that label will not get in the way of your lovely glass. So I'm going to save as. Why? Because it's Maya. Maya hates me just like it hates you. Right. So first thing I want to do, we're going to work on getting reference. So I want wine. I want a wine glass. I'm going to go into perspective here. Let's frame that up. As you can see, you got geometry inside it, and there's my bottle. So whatever your favorite search engine is, don't forget, set it up so that when it displays the images, it displays the largest quality or largest size image you can get. So let's go wine in glass outside. Day, why not? Be specific. Now, I didn't tell it what I want because I want to see. Do I want red wine? Do I want white wine? Anything that looks CG, avoid like the plague. You want photo reference. So not bad, little bit on the dark side. Now, if you remember from Friday when Frank went over the look development guide, we do have some very special requirements. So Frank gave quite a comprehensive little talk on Friday. So if you missed it, you might want to come to lab today and ask him about it. Anyway, what we've got going on here is we want to find out exactly what we're doing. So remember, no white backgrounds for reference. They need to be in an environment. They need to be lit appropriately. So if you're doing a night scene, you want to try and find night reference. It's good to find additional reference. Maybe you want some daytime reference so you can kind of see how the color looks a little bit better. But ideally, you want your materials to look like the reference because they are in the same type of environment. Don't distort your reference. Make sure that we can see through the wine. Wine like this is super dark. We really can't see through it. So consequently, we can't tell whether you understand how to get the right look. Also, bottles need to be completely empty. You can't see through them. So bottles need to be empty. Even if you've got a dark red wine, we need to be able to see through it. That would not make a very good, appropriate picture. In fact, you can't even tell, it's so dense, the shadows don't even let any color through. So this isn't bad, but it's inside. So something like this would work. You know, can see through it. The glass is clear. The wine we can see through a little bit. This, nope, this is mixed with some other juice. We don't have ice cubes. Don't get wine with ice cubes in them. Okay, that's not too bad. That's kind of, you know, it says pink wine, so it's Zinfandel, rosé, whatever you want. Not bad. That one's not too bad. It's really hard to tell what color it is. Almost looks like water. This one, low level lighting. We're daytime, try and find appropriate reference. This might, you know, really kind of low level light, almost night, but not quite. All right, don't forget tools, size, large. Large, large, large. So now you can kind of decide, do I want red wine? Do I want white wine? Do I want pink? So somebody make a suggestion. What kind are we looking for? Okay, Marie likes rosé. So how about rosé wine in glass? Okay. So a lot of times it looks almost like the rosé is served chilled. So you can see we got frosted on the outside of the glass. We're not really worried about that. Where our glass is, or our glass and our bottle are room temperature or ambient temperature. So sort of something like this. You're not really going to see the glass outside with cold wine in it. All right, so we want rosé. That's not bad. That's a little chilled. You can see it's got that frosted look. Now, in reality, if we were going to do this, remember, it's not the glass that we're really seeing be frosted, it's the contents of it. Although in reality, there would be, the glass itself would be cold down here. That would require some maps. We're not at that point yet. So like I said, run away from that. Take cover, shelter in place. All right, so we're looking for rosé, and you can see a lot of them have clear bottles. Our bottle needs to have color, but I'm also looking down here, and that amber bottle is kind of interesting. All right, so let's make a decision here. That's not too bad for our wine. That has no stem on it. That's one of those stemless wine glasses, which kind of remind me of the Weebles. Like they kind of wobble, but they don't fall over. Now, I want a wine glass where when I make a mistake and knock it over, it spills and shatters. I mean, that's a wine glass. So very pink. Just try and find one that you like that's kind of appropriate. One where you can get a good sense of the color and you can get a good sense of the environment, just a little bit. Okay, this one is kind of magically floating. It looks like, I don't know, some kind of alien wine. It's being abducted. All right, that's not bad. Why don't I try that? Not very big. So wait, how did that show up? Tools? Oh, because I reset my search. Pink wine in stemmed glass on a table for your enjoyment. Sip a lovely cocktail. All right, that's not too bad. No, that's sparkling. I don't want that. We don't have effervescent bubbles in our wine. All right, here's a decent one outside. You got your choice. That's a little too red. We couldn't use that, but the white and the pink we could. . So Yeah, I don't like the bottle. We can't use the bottle. We don't want the sippy cup. The wine isn't too bad. So if you can find wine, a glass, and a bottle all in one shot, perfect. But you may need separate reference for the bottle. So here, this one's not too bad. Let's see if I can save it. Is that going to allow me to save it? Oh, a JPEG. Yes, maybe. No. It's sparkling wine. I was tricked. Nope, can't use that. Sorry. I guess I should have seen that. I thought it was too good to be true. Dang it. Okay. No, we're not doing boxes of wine. Gotta have a bottle. That's not too bad. Yeah, kind of small, of course. Simple, nice, clear, reflective wine glass. Got some pink wine in there, rosé. Let's try that. Save image. All right, that is a JPEG. Okay, that looks like it'll work. Now, downside is we can't see a reflection. It's not, or we can't see a shadow. It's not on a table. So, I mean, it's nice if we can find a shadow from the wine. Rosé. So even this one, big, I don't like that. It's nasty looking. All right, this one looks sparkling. Well, I don't want to go to the website. You can see a shadow here, sort of. That looks really low res, but it's saying now it's a thumbnail. All right, what about you? Well, that looks like it's red wine. Michigan wineries. Again, no magical matrix. Okay, let's go all the way back up to the top here. No, definitely not. No, 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 no. So that's inside. Don't want that. We've got an exterior scene. So like I said, you may want to find multiple reference. So this one's not bad. I can see a little bit of a shadow, but I can't see the wine itself. But I get the idea. So I think I'm still going to go with this one, at least to get the wine, but the wine glass and the wine inside the glass. All right, so really reflective, you can see. Now, the thing you have to take a look at is how rough is it? Well, it's got what we call depth of field, where the photographer blurred out the background and left the foreground in focus. The trouble is everything looks blurry and it kind of fools everybody into thinking, oh, this is a really rough glass. Not really. So yeah, rosé. Let's just go rosé wine glass outside. Let's change it up. See if we can find any different reference. Much as I don't like this, this is actually decent, but not sitting on a table. Well, that's outside. That'll give me an idea. All right, it's clear bottle, but I'll have to find reference for my bottle somewhere else. All right, so got reference, usable reference, I think. So let's make clear glass. All right, so clear glass is not really that hard. We found reference. Now we need to assign a new AI standard surface, Shift T. Shader, AI standard surface. I'm going to rename it wine glass. If you're very clever, whoops. If you're very clever, you will name as you go. All right, so first thing you want to do, shut down the base weight. All right, now, by default, our index of refraction is 1.5, right? We shut the base down, that's off. Specular, the weight's going to be up all the way by default. The color is going to be white, perfect. The roughness, all objects have some roughness, but this is going to be fairly rough. So I'm going to turn that down for now to, well, let's just go 0.1. All right, and transmission, I'm just going to turn it all the way up, which is going to make it transparent glass. So let's see what we get. I want to make sure that my bookmark is set for the close-up shot. There we go. And let's see what we get. All right, so you can see I've got clear glass. Now you'll notice that the transmission roughness is off, but I've got kind of a rough looking reflection. So I'm going to turn down my glass roughness to like 0.01. It's usually like my go-to for glass that is fairly clear and clean. Kind of like these. It's fairly clean. You can see some really nice reflections on it. Same thing here. This is actually very reflective. So there we go. We made glass, but the problem is we have no shadow. It looks weird to have, well, basically our wine inside is like a lump of clay sitting inside the glass. So this is where we need to use our simple utilities, right? We're going to use a gamma correction and something called a sampler info node that will allow the edges to be a little bit darker so we get an actual shadow. All right, so the process to do this, under transmission, we click on the weight checker button here. That's basically, we want to connect something in there, right? Create render node. Most of the time we're up here doing file or something else. We want to go under utilities. Utilities are alphabetical. which means gamma correct, which is what we want, is down under G. Here it is, right there, gamma correct. And then you say to yourself, oh my God, what is this? Okay, it's the same connection every time. So for the gamma correct, we want to take the out value, expand it, and we only want X. Because we only need one of the three X, Y, Z values to drive the edge of the glass. So we're going to choose X, seems to work the best. On the right side, we want to connect it to transmission. And basically, X is us looking kind of directly at that glass, where the camera sees it. So outputs, out value X, inputs, transmission. Once we do that, we hit close, and now you go, it's completely black. No worries. The reason for it being black is we have nothing in the value. But here is where we want to crank up the gamma. The gamma is going to go to 4, and all the other, which is X, remember X, Y, Z. So this is going to be 4, and the other two values are going to be 0, because we're not using Y or Z. Now you still say that's disgusting. But this is where in value, we click the little checker button. This is where we plug in something called a sampler info node. So we go under utilities again. We scroll down, this time to S for sampler. Sampler info. Here, again, everybody's like, facing ratio. That's the facing angle to the camera. We click on that for output. We want to go over to value. Now it's grayed out because we've got something plugged into the gamma of the value, but we're going to expand it. Now they're not grayed out. And the reason, another reason this is also grayed out is because facing ratio only wants one input, not 3. So we're going to use the value X. So now we have glass with a shadow. So we're almost done. Now we go back to our material. We want to scroll down to advanced, and we want to turn caustics on. So let's save this. First off, my render settings are super high. Oh, no, 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 no. Let's just go to defaults for now. All right, so let me keep this so we can compare. Hit render. Good. So now I want to turn caustics on. So now notice the difference between no caustics and caustics. Adds a little bit more sparkle to the glass. Now, something else we want to do is let's crank up the indirect specular to 1.1. Save this. Well, let me get rid of this. Delete. Let's put this back at 1. Just so I can get a shot of it. Let's do that. Now let's turn it up to 1.1. All right, so it allows us to see through a lot better. All right, so this is after we add the gamma correct sampler info, then we add in a little bit of sparkle with caustics, and now we crank up the indirect specular, and it allows our glass to be a lot more clear looking. And we have a nice shadow that kind of reasonably resembles what we were looking at here, minus, of course, the really complex caustics. We got a shadow. Now we got to get rid of the lump of clay inside the glass. All right, so any questions so far? Now, I've got a checklist for you guys on how to do this, but I want to run through it first without the checklist, just so I can kind of explain everything as we go through it. All right, so now we're going to kind of do the same process for the liquid inside the glass. So I'm going to go select the geometry, wine glass. You notice the wine glass had a weird icon. That's because the wine glass itself is NURBS. The wine geometry inside that's a poly surface. So we select the poly surface, Shift T, add a new Arnold surface. Let's call this rosé wine. And we're going to go through sort of the same process. All right, so let me keep this. Let's get rid of this and that. There we go. And let's fire it off. So let's make glass. We've got reference already for our wine right here and right here. It's basically the same color. Kind of like this one a little bit better. All right, so first thing we want to do, we've found reference, we've assigned the material, we turn off weight. Turns it completely black. We've got dark matter inside our glass. Now, there we go. And let's bring that to the front. Okay. So dark matter inside our glass. Let's go ahead, turn the roughness down. Most liquids, especially wines, are fairly clear. I mean, that's the whole thing with wine, the clarity of it. You know, you don't want to see particles floating around. You don't want to see cloudy wine. That usually means it's probably starting to turn into vinegar. We've got the right index of refraction. So far, life is good here. Now, we're going to turn up transmission, right? And right away, that's going to give us glass with no shadow. All right, fair enough. Let's add in right now, before we go add in the sample, the gamma correctant sampler info, let's actually make it color. Now, I can try and guess, maybe use the color picker, but I'm going to double click on my transmission color. Brings up my kind of advanced color picker. Under color wheel image, let's load in the reference I have on the desktop. So I got this, I got this. I'm kind of partial to this one. Let's try it. So just left click. And now I can try and find a nice area. I don't want to use dark areas. And I don't want an area that's too white. I'm going to try and find something that sort of looks like the wine itself. Now, I'm taking a look down here at my value, and that value is pretty low. I mean, I've got some dark in there, so I'm going to turn that up a little bit. And a lot of times I like to try and keep the value close to 1 unless the wine is actually dark, like deep red wine. And, saturation's not bad. It's looking a little wonky. So let's go and add in our sampler info, or actually our gamma correct and our sampler info to the weight. Because right now it just looks way too pure here. So transmission, weight, input connection, utilities, it's alphabetical. We want to go down to gamma correct. We want the out value to be X, and we want to plug it into the transmission. Close. Let's change our gamma. Well, let's see what happens, because last time I didn't see what happened when I turned the gamma up. So just for fun, just to show you why we turned the gamma up, let's go take our value and plug in our sampler info node. So again, input connection, utilities, let's go down under S for sampler info node right there. Okay, sampler info, under outputs, facing ratio, under inputs, near value, click X, click close. Looks really dark. But it's funny, our shadow doesn't look that dark. So let's go back to the actual geometry. There we go. There's my gamma. Now, if you lose track of this, you can also open up the hypershade. And you can graph your network. Now, a lot of times I like to use the hypershade just so I don't have to kind of step through all the connections. Like here, if I want to get to the material, I can just select the geometry, go to the attributes for it. If I want to get to that gamma, I got to go through the transmission weight, click on that. Here in my hypershade, I can just right click on my wine, which is rosé wine, right click and graph the network. And there's my gamma correct right there. I can just select it kind of in a non-linear fashion. So however you get to it doesn't really matter. So now let's crank this up to 4. You can see it got brighter, which is what we want. Now we're not using Y and Z, so they're going to be 0. Still looking a little kind of wonky on the edges there. So let's go back and let's go to advanced, turn on caustics, add a little bit of sparkle to that wine, and then increase the specular, indirect specular to 1.1. Now, something else that's going on here too is that we do not have the right index of refraction for wine. Right now, we are using the glass. So we need to find out the index of refraction for rosé. Now, you can try looking it up in the refractive index database. So let's see, simple inorganic, I doubt they're going to have wine. So here's glass. What do they got here? Multi-purpose glass. I doubt they're going to have any liquids here. So optical glass, I mean, there's a ton of stuff here. Air, no, 3D. Oh, we got metals, plastics, liquids. Yeah, let's go liquids. Oh, no, I don't want mercury. I don't want acetone. I don't want benzene. Okay, that's not going to help me. So why not use the great Oracle Google? So let's go index of fraction rosé wine or refractive index rosé wine. That's red wine. Don't know if that's going to give me what I want. Of course not. No, 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 no. Download citation references. I don't want to request that. Liquids. Let's try that. Ooh, refractive index for common liquids, solids, and gases. All right, so HIJKL. No, I'm not seeing any liquids. Water. Don't want that. So alcohol, methanol. So a lot of good stuff here, but I'm not actually seeing wine. I'll be happy to get wine. Okay, that's where I'm at now. Refractive index. Just to have some really good references, but just like anything else online, you come back to it and one day they took the site down. So there you have it. Oh, this one does actually have stuff in here. Refractive index. I don't want table of contents. I want to see your results. Theory, results, and discussion. Come on. No? Next. Oh, pay per article. No, thank you. No, no, no. Cheap, 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 cheap. That's what I want. All right. So looks like it's a little bit more than water. 3.3, or it's 1.36, 1.38. Let's try 1.37. 1.37. And let's hit render. There we go. So let's compare. All right, color's not too bad. It's pretty close. Let's take care of our bottle. Want to find reference for a wine bottle. And remember, empty wine bottle. Empty wine bottle, outside day. All right, so it's got to have some color in it. Avoid anything turned into a light. Avoid these. These are not empty. Neither are these. Let's just try empty bottles. Tools, size, large. Okay, again, we're not doing lights. That looked like a good party. So did that one. And actually, for this one, you pretty much got your pick. They're mostly green, a couple of amber bottles. Not too bad. It's like there's still some liquid in a few of them. That could be a little confusing. So if you've got multiple objects in your reference, label or circle the one you want to use. Okay, so a couple wine bottles here, but there's also a lot of other alcohol bottles and beer bottles. Too confusing. This one, nice, but really dirty, and I wouldn't drink it. Avoid artificially colored bottles like this one. If you have wine bottles at home and you want to take reference, go for it. Here's an interesting idea, but not going to work. That one's, yeah, that's okay. Not really good for environment reference. All right, let's just try empty bottles outside. All right, we got some clear, got a green one in there. Kind of like to get some green and amber to choose from. All right, that's not bad, actually. Let's see, can we use that? Save as JPEG? Where are you? There we go. Okay, well, that would work. So we've kind of got like an olive color, a darker one, different shades of green and amber. Which one should we do for our rosé? Can't do the clear because it's got to have a color. So think about that. Let's make this bottle glass. So select, we found reference, select the object, assign a new material to it. Shift T, Arnold, AI standard surface. First thing we want to do, turn off the base weight. Check your index of refraction. Good. Going to lower my weight. This time the bottle, probably going to give it a little more roughness, like 0.02 instead of 1. Because these guys don't look all that. Well, they're kind of clean. They're not really smudgy. All right, we can take a look. All right, so weight, color for spec is good. Index of refraction is good. We know we're going to need to do the gamma correct and the sampler info to get an accurate shadow. So transmission weight, click the checker button, go to utilities, gamma correct, connection editor, outputs, out value, X goes to transmission input on the right, click close, gamma goes to 4 in X, 0 in Y, and in Z. Under value, this is where we connect the sampler info. So again, create render node, utilities. Utilities are alphabetical, go down, sampler info, facing ratio for the output. This is the sampler info. We want it to go into the value of X. In our gamma correct, we hit close. Now we should have a clear bottle. So let's go back. It's a little on the dark side. Go into the light. Turn on caustics, a little more sparkle. Crank up the indirect spec to 1.1. There we go. Now, let's add color to it. Color goes into transmission color. I'm going to double click, load in my new reference, which is right here. And which one should we go for? Chanel says middle green, this one, kind of like right here-ish. So I click on it. I click done, and it looks a little dark, especially compared to how bright it looks in the reference. So a couple of things to do here. Looks just a little lighter. So what I'm going to do is go into my color, and I'm going to use the simple color picker to adjust the value. So I'm simply going to come in, click once on the color chip in transmission color, and turn up my value. Let's go 0.8 and see what we get. Let's compare that. That might be a little high. So let's go 0.75. Let's see what that looks like. A little better. Not bad. So now we've got glass bottle, we've got glass, clear glass for the wine glass, we've got our rosé inside there, all based on our reference. All right, let me set and save that. And as promised, let me show you there it is, the checklist. All right, so I'll take a screen, upload it for you guys. Okay, Arnold glass checklist. So if you are watching the archive of this, I'll give you a chance to kind of freeze it, and you can then, there we go, upload it for everybody. There you go. If you're watching this in an archive, freeze it. Make sure you're doing high def, the high def version on YouTube, and take a screen of this. So again, find reference, assign a new AI standard, turn the base weight off, specular weight to 1, specular color is white, that's default. Adjust the specular and transmission roughness based on your reference. Like I said, for glass, for most liquids, it's going to be really low. Adjust the index of refraction, default's glass. We had to go back and change the index of refraction for the wine. We used 1.36, I believe. Okay, in the transmission weight, in order to get proper shadows, we have to plug in a gamma correct utility. So here's the process. You click on the transmission weight input connection, right? You select the gamma correct, outputs, out value X to transmission, close. Gamma correct attributes, the gamma in X is 4, X and Y are both, Y and Z are both 0. Then in the value of the gamma correct, we plug our Maya sampler info node in. In the connection editor, facing ratio on the left under inputs, we select the value, go to value X, hook it up, hit close, transmission color based on your reference. Turn on caustics, increase the indirect spec to 1.1. So far, life is good. If you need to, check your ray depth settings in Maya, which are right here. Arnold, ray depth, totals 10. I turned this one down. So that's why this is looking really dark. So specular, let's go to 10. Let's go to 10 for transmission. Now let's render. Oh, that looks much better. Now we're getting enough light bouncing around. We're getting enough light going through it. It was dark on the edges before. Always use the checklist. That's why I'm a big fan of the checklist. And also, don't do like I did. Don't assume, oh, all the settings are standard. No, because the person who worked on this before was messing around with stuff. I'm not going to mention his initials, but it's Tony. He's fired. So you guys get the idea. All right, went over a lot of stuff. When we come back, we'll do the interior. I'll show you how to do the windows for the interior. We'll do a glass bottle, and I'll show you how to approach doing that thermos, that, what is it? The brushed metal stainless steel thermos on the computer desk. So good time. Let's take a 20-minute break. That'll give me a chance to render out the first part of lecture. But before we go, Nathaniel, Marie, Kentavious, Frenzy, Derek, Darian, Clifton, Chanel, Brianna, any questions? I totally would understand if there are a billion of them, but hopefully the checklist will help a little bit. So on Friday, I gave you guys the metal checklist. Today we got glass. Between those two, that should help you with the complex, the complex connections, basically, that we have to kind of go through to get it to look right. Okay. So let's take a break. And where is my keynote? There we go. So keynote, let's come back at 11:23. Oddly specific, but there you go. All right, so I'll see you guys at 11:23. Turn that off. I'm going to stop recording.